And welcome back to the NeuroBytes video experiment series. In a previous video, you learned how touch sensory neurons work. Today, we will learn about another sensory neuron simulator, the NeuroBytes Pressure Sensory Neuron. This module simulates pressure-sensitive neurons in your skin that contain Pacinian corpuscles. These are nerve endings in your skin that are sensitive to both vibration and pressure. When pressure is applied to your skin, from putting on a shirt in the morning to bumping your arm against a table, the Pacinian corpuscle senses that pressure and the sensory neuron sends action potentials to your spinal cord and brain that correspond to the amount of pressure. This is called rate coding, and it is one method used by the brain to figure out how intense different types of stimuli are, including light, sound, and touch. One side of your NeuroBytes pressure sensory neuron has a circular force-sensitive resistor, and next to it is an LED that changes color when an increasing amount of pressure is applied to the pad. Let's experiment with how that works. Power up your pressure sensory neuron with your battery pack and power cable. When you see the power button on your screen, this tells you that your simulator should be powered up. Plug an excitatory neurotransmitter cable into your pressure sensory neuron and then connect it to one of the long dendrites on the interneuron. Both NeuroBytes should now be lit up with green LEDs. Now, slowly apply pressure with your thumb to the force sensor. See if you can get the LED to change from green to yellow to red and hold it there. In your skin, this is similar to a touch so light that it does not cause the Pacinian corpuscle to fire an action potential, which means that you would not even feel that touch because your brain doesn't get the signal. Now press on the simulator a little harder until the LED flashes white, which indicates an action potential has been fired. The more pressure you apply, the more action potentials that are produced, indicated by a rapidly flashing LED. After a few seconds, you'll notice that the LED starts flashing slower, indicating that there are fewer action potentials being produced. This phenomenon is known as sensory adaptation. Try resting your hand on a table. Notice how its surface is immediately felt on your skin. Keep your hand on the table for a bit longer, and you'll notice that that feeling disappears. This is because the sensory neurons that were initially simulated when your hand came in contact with the table have adapted to the table's surface by firing fewer action potentials. Increase the pressure from your hand to the table and consider the reaction of the Pacinian corpuscles and action potentials that are being sent to your brain. Want to share what you've built? Visit us at www.neurotinker.com and show us your brain on NeuroBytes.